Okay, so we've got these three figures. All these points are the exact same, okay? It says, however, each figure has a different curve fitting the data. The equation for each curve is also shown. Now, the other thing that you have to know is what do these numbers stand for and what do these numbers stand for right here, okay? What are these numbers? Well, right here it says the data points show the item's value Y in dollars. So this is our dollars on each of them. Okay, these are our dollars. And the other one is at a time X in years. So this is our X in years. I don't know why I'm putting X. This is our time in years, okay? Because you need that for the problems down below. Which curve fits the data best? 1, 2, or 3? Sounds pretty easy, right? 1, okay? So this is the one, this formula right here fits it best. Well, or you're going to say figure 1, however it is that you want to answer that question. Okay. Use the equation of best fitting curve from part A, which is this. To predict the value of item at a time of 15 years after its purchase. Round your answer to the nearest 100. Okay, that's 2 decimal places. From up here in our graph, we know that X is our years and Y is our dollars. So now you just plug in what we know. 66 times 1.12 raised to the 15, because in this case, it asks 15 years. So you just do this on your calculator. 66 times 1.12 raised to the 15th power. And we get $361.26. Because what you have to do is you have to ask yourself, is it closer to 25 or 26? And it's closer to 26. Pretty easy. Does that help, Jimmy? Okay. Next page. All right, modeling growth and decay. You're going to see the formula. You're going to see things that look like this, okay? But it comes from this down here, and we'll get to that. But the key thing is, when you have this here, A represents the initial amount. Initial amount, meaning our starting point, okay? If it happens to be money, we start with $5,000. That's where the 5,000 is going to go. If we have 350 bacteria and it's going to grow, then that 350 goes in that spot. Okay. The B value, what's in here, okay, is called the growth or decay factor. If B is greater than 1, it represents a growth. If it's between 0 and 1, it represents a decay. Okay. We're going to need that for the next couple questions. The growth factor is related to the rate of change. Right here, you have 1 plus the rate. Here you have for a growth, 1 minus the rate for decay. So the price of a certain item that is X years old is defined by this formula, this function. It's going to ask, what is the initial price? Well, the initial price is a number, is our A. So our initial price of the item is $300. Now, my question is this a growth or is it a decay? Well, you look at your B value, which is 1.08. If it is greater than 1, it's a growth. Okay. If it's between 0 and 1, it can't be 0 and it can't be 1. So if it's between 0 and 1, then it's a decay. In these problems, if it's greater than 1, it's a growth. If it's less than 1, it's a decay, because you're not going to see 1 or 0, either one. Now, by what percent does the price change per year? Well, this here, you get that from 1 plus R. Well, the rate, the change per year is a percentage. What if this is 1.08? What is my percentage? Do you know? Say it again. What you would do is you would subtract 1 from this, okay? And you get 0.08, but that's not as a percentage. That's the rate as a decimal. So you're going to have to move your decimal 2 places to the right. So it's an 8% change. Does that make sense?
Yeah.
Okay. Again, you are taking this and you're moving your decimal 2 places to the right. Is it always 2 places? Yes, always. Percent to decimal, 2 places to the left. Decimal to percent, 2 places to the right. Right, because here we're multiplying by 100. All right, try this one. Try to answer these 3. Okay, what was the initial price of the item? Yep, it's at 523. Very good. Growth or decay? Decay, good. What's the last? What is the change? It's still 8%. Okay, because it's below this. It was a decay because this was between 0 and 1, right? And remember, it's 1 minus this. 1 minus, or this minus the 1, yeah, 1 minus this, okay, is how you'd figure it out. And that's where you get 0.8%. I'm sorry. Let's try this again. It's 0.08, which is again 8%. Basically, you take this and subtract 1 from it. 1 minus that. God, I can't say this right. I'm in trouble. Okay. Yeah.
So in the second one, you're taking 1. With the first one, you add 1 to it?
Really, what you do here, you subtract 1 from this.
Yeah.
Here, you subtract this from 1.
Okay.
Does that make sense?
Yeah.
Okay. I didn't explain that one very well. I was having
Yeah.
trouble. Okay, but always using 1. Yeah. So right here, or basically you can think of it this way. How much over 1 is it here? How much under 1 is it here?
Okay.
Yeah. All right. Right here, Susie has a Petri dish with 350 bacteria. They are growing at a rate of 17% per day. Define your variable and write a function to represent the situation. Okay, so here's what we're going to do. It is a growth. So it's a growth, so we use this one right here. The A times 1 plus R raised to the X. So we are going to use f of x equals, it's our initial, which is 350. It's a growth, so it's 1 plus, and what are we going to use instead of 17%? What are we going to use? We are going to think about this. I don't know, what did you say? Yes, 0.17, is that what you said? Yeah. Okay, yeah, I was thinking you had a 0 in it. Really what this is 17% over 100. The reason it moves left 2 places is because you're dividing it by 100. Watch this, when I do 17 and divide it by 100, you get that 0.17. So that's why, but the shortcut to it is just move it left 2 places. So you have 0.17 or 0.17, okay? I'm lazy about writing my 0 in front. Raised to the x power. Because we do not know how much time, it didn't say to solve it, it just says to do that, okay? So, all right. Now, if it gave us the amount of time, then we'd be all right. We could just plug that in for x. But now what we have to do is just simplify this. 1 plus 0.17 is 1.17 raised to the x power. So that's our function. See if you can write this function right here. It's a decay, so be careful now. Because they are dying, so that's a decay. So you should have used this function because they are dying, so that means they're going down, okay? Our initial is 550. We're going to say 1 minus our rate, which is 0.09, because we're going to move our decimal 2 places to the left, raised to the x power. So that simplifies to 550 times 0.91 raised to the x power, and that's our function. Questions? All right. Now, when Dr. Matheny taught you the other day, okay, you've seen this before because that was part of that section. Now, before she got to that though, she used this one. Amount equals P times 1 plus our rate divided by the number of times it's compounded, raised to the NT, where T is always in years, okay? Now, I'm not exactly sure what she started with because I don't remember the notes, but you use this formula. The key thing is I'm going to give you both of these formulas. You have to know which one to use, okay? You will use this one for everything, okay? Except when you use this, and I'll tell you the word you're going to look for, okay? This one here is used for compounded daily, compounded weekly, compounded monthly, compounded annually, compounded semi-annually, quarterly, okay? This is compounded continuously. That tells you to use this, okay? This one, again, you'll use for everything else. Compounded daily, compounded monthly, compounded quarterly, compounded weekly, okay? This will say compounded continuously. When you see that word continuously, you're like, I got to use this, okay? So Laura wants to buy a bond that will mature at $6,000 in 6 years. How much should she pay for the bond now if she earns interest at a rate of 3.5%? So we're going to use 0.035 per year, compounded continuously. There's that word. That word tells you I'm going to use this A, which stands for the amount in the future, which in this case, it's $6,000, equals your principal, which is how much you're going to invest now, which we don't know that. That's what she wants to know, okay? Times E raised to our rate, which is 0.035, times our time, which is 6 years. Okay, these are the three things that we need. So we have E, oops, sorry, I put that in the wrong place. This was just the formula that we were using. E to the rate, raised to the rate, which is 0.035, times time, which is 6 years. Time is always in our years. Okay, we need to solve for this P. Okay? Here's the thing. I'm going to go ahead and simplify this part right here. So I'm going to have 6,000 equals P E to the, I think it gives us 0.21. I did this last class. 0.21. Okay. I want to know what P is. How are we going to solve for P? Add, subtract, multiply, or divide. Divide. Okay. Some of you are going, well, what about this? Remember, E is a number. Okay. E stands for this number right here. So if we had this number, now again, we are taking that number and raising it to the 0.21, okay? E to this power right here gives us this number right here. I don't want to write all those numbers out, okay? I know that this and this are the exact same thing. So this means multiplication. So what I'm going to do is divide by E to the 0.21. Because that's shorter than writing 1.2336 and so on, okay? It's a lot shorter than writing that out. So now these cancel. So I'm left a P over here. Here, I'm just going to do 6,000 divided by E to the 0.21. And it says round to the nearest cent because we're talking about money. So is this going to be closer to 50 cents or 51? This is 51, right. So we have $4,863.51. Now let me explain this to you because does anybody have a bond in here? Okay. Not many people, yeah, what is it, right? Okay. I don't even know. I don't know if they even do it anymore. I'm old, so yes, I have bonds. I even have bonds right now. Okay. Because when I was young, like 5, 6, 7, I had those grandparents that didn't even toys or us toys. They gave us stuff like bonds. What it is they go to the bank and buy a government bond. They pay $50 for it. They give it to us, and we would hold on to it for however many years it was. I'm going to say 7 years. And at 7 years, I would get $100. It matured to that. It was a $100 bond, but they would only pay $50 at the time that they purchased. If I waited at that time, I get more money. Well, what I found is I found some of them, and I went to the bank back in my 30s, and they were like, you should just hold on to it because it's worth a whole lot more money. You hold on to it than cashing it in, and it keeps going up. Because again, I've allowed the banks to use that money I have in my bank. So,
You know, that's what it is. What this particular person would have done was, that's what she would have given the bank, and then waited 6 years and gotten $6,000 for it. Now, again, I don't even know if they do bonds anymore, because we don't do that for Connor. But the other thing is, I bring this up and I talk to all my classes, because you guys are getting closer to having what I call a real job, okay? Real jobs are not ones that you get paid by the hour. Real jobs, when I say real jobs, those are jobs, trust me. You just don't get what you probably deserve, okay? When I started teaching, that was my first, not substituting, but teaching. That's my first real job, because I got health insurance. That's a big, any kind of health insurance. That's what real does. Okay. When you get to that point, your full-time job, right? Start at your age. It's probably going to be 23 or 24, and maybe a little bit younger. If you can afford it younger, then do it. Start putting so much money down. Okay. I only know this from experience. When I first started teaching, I did not get paid money. Okay, I didn't. But in I never go to that. Okay, not what I have to. My check gets automatically deposited, so I never see it. It actually shows up on my bank account. Hey, this deposit was made. Well, I started this back when I first started teaching, because that's what you did. What I would do was, when I first started teaching, every 2 weeks, we were getting paid once a month, but I would have them take $25 out of my account, and I put it into it's Forest Man. They're still in business, but they don't do this anymore. That I opened up an account, and every paycheck they take $25, and it goes into this account. It didn't matter to me, because I knew it was going in, but I didn't miss it. I knew if I say I was making $300, okay, so I was getting $275. Okay, think about how much money you guys waste. You ever go to a convenience store? All right, you're paying $2 for a water where you can go and get, or you can get it out of your sink, actually. Okay, but you in a grocery store when you get as much. And you guys go to Chick-fil-A, Starbucks, any restaurant. I don't care if it's fast food. You can't go through the fast food line without spending $10, right? So if you go out to eat twice a week, 3 times a week, just for doing lunch, probably just $25 right there. You can afford it. I'm not putting it down, because I go to my Starbucks a lot, and that's between $6 and $7. And I used to go to Dunkin' Donuts and get my $2.69 coffee, which was more than what I paid anyway. But then I can't make the Starbucks at home. I tried to, and it doesn't work out so much. So yes, if I couldn't afford it, I wouldn't do it. But what I'm saying is, I started at $25. Then after I worked, like, let's say a couple of years, I was getting paid enough to get wages. Then I went to $50. Then after so long, I went to $100 a month. Okay, I would just put in $100 a month. I didn't miss it. I should have done more, but I was let it ride. But what was nice is, when I stopped teaching, when I had Connor, that I took 7 years off, I didn't have any cash flow going into it, so they halted. I still had the money, and I still was getting 4% in that account, but I didn't miss it. And now when I get my little statement, I'm like, oh, that's a nice little chunk of money. And I didn't even miss it. And right now I don't need it. I hope I never do. I will cash it in, okay? But I kept it in there, we had Connor and their money pits. But that would have helped, had he not played basketball and got money for it. That would have helped for his college, or for his college. Okay? Now, not all parents do that. So he's just lucky in that case, but we're lucky that we don't have to yet. So, and he doesn't go to community college. The nice thing with you guys is you are at a community college where you do for 2 years. Don't blow it. Don't blow that, okay? Even if you fail a class, it's better to show up every day and fail than stop attending and fail
for financial aid purposes. They'll give you, you know, they'll give you one strike. Okay, so that it just looks better. Anyway, start saving money. All right. Anyway, all right. This one cracked me up last because who does this? Laura places a bottle of water inside a cooler. As the water cools, its temperature, C of T in degrees Celsius, is given by the following function, where T is the number of minutes since the bottle was placed in the cooler. Okay, so we got this function. Basically, this is our minutes. This is degrees Celsius. Laura wants to drink the water when it reaches 17 degrees Celsius. Isn't that what you guys drink your water at? Oh, I don't know. Okay, mine's room temperature, so I'll drink it cold, I'll drink it hot, warm. I just won't drink it hot. Okay, so when it reaches 17 degrees Celsius, how many minutes should she leave it in the cooler? Round your answer to the nearest tenth. That's 1 decimal place. Okay, so we need 17 degrees. That's going to go here. Equals 7 plus 15 e to the negative 0.038. I know that this is getting cooler. It starts at room temperature maybe, and it's getting colder. I know that because my exponent is negative. Okay. If it was positive, it'd be getting hotter. So I need to, now here's the problem. RT is now, our missing variable is in the exponent. Okay. So what we need to do is isolate that part first, that e to that power first. So I'm going to first take the 7 to the other side by subtracting it. And I get 10 equals 15 e to the negative 0.038 t. Well, this is just saying 15 times that. So we're going to divide by 15. And if you guys want to, you can leave it. We're going to end up using our calculator anyway. So if you want to leave it as 10 over 15, that's perfectly fine. I'm just going to reduce it to 2/3 just because it's not as much writing. Equals e to the negative 0.038 t. Now, this, in order to see how our exponent is in our, see how our variable's in our exponent, we got to free it up, okay? So the way you're going to do that is this has a base e. We are going to use those cancellation properties that, I think we did it on Wednesday of last week. It was these right here in homework 20A. May have been on Friday for all I know. Okay, we're going to use this property right here. When you have log base b of b, it frees that up and it gives us x. So instead of log base e, what is our base right here? E, right? What uses base e? That ln, right? The natural log. If I take the natural log of this side, these two things cancel each other out, and it frees up that exponent to this. Now, the problem is if you take the not the problem, but if we're going to take the natural log of this side, bless you, we have to take the natural log of this side. You've got to do the same thing to both sides. Now, so over here, I have the natural log of 2/3. I just like my fractions in parentheses. They don't have to be there. We're solving for t, so we are going to divide by negative 0.038. So I'm going to have t equals, and I'm going to plug this into my calculator. The natural log of 2/3. If you left it as 10/15, that's perfectly fine. It would give you the exact same thing. Divided by negative 0.038. And it would be 10.7 minutes. 10.7 minutes. So she would have to leave the water in the cooler for 10.7 minutes for it to come to 17 degrees Celsius. Yeah. All right. Now, this next problem is going to be really weird for you. So when you go to Alex and you work on it, take this out, okay? They give you this formula right here. A radioactive substance decays according to the following function, where this, the y sub 0 is our initial. Okay, so this is our initial. I don't know why I'm writing that two different places, but I will. Okay. The initial amount present. And y is the amount present at the time in 10 days. So this is how much in the future. Amount in future. Okay, and the t represents our days. So the amount in the future would be like if I said 10 days, it'd be the amount that we'd have in 10 days. If I said it was 20 days, it'd be the amount that we have in 20 days. Okay, find the half-life of the substance. Do not round any intermediate computations and round your answer to the nearest tenth. Okay, you do not understand science. I know about half-lives because I've had to teach this in my 1710 class for years. And I know isotopes, whatever the heck that is, has half-lives, okay? So here's the thing. And when you figure out a half-life, you want to find out the time. Now, the reason this is going to be really weird is they don't give you anything. They don't give you your initial. They don't give you the amount in the future, and they don't give you the days, do they? Here's how you can find it, though. Here's what I want everybody to do. We're going to put y sub 0, and we're going to pick y, okay? I want you to pick an even number. Make it larger than 2 then, okay? Pick an even number for y sub 0, because everybody's going to pick different numbers. But I promise you it'll work out. I'll tell you what to do with it, okay? Everybody got their number? They wrote it down? Okay. I'm going to pick 100. Okay? Yours is probably different. That's perfectly fine. Okay? Half of 100. Okay? You're going to pick half of your number and put it here. Okay? So yours will be, somebody give me their number. 10, so yours is gonna be 5, right? Okay, all right, so now we know everything. We can take these numbers and plug it into this formula. We know everything but t, but watch what happens. Okay, I'm gonna put 50 here. You're gonna put whatever yours is. I'm gonna put 100 here because that was my initial. E to the negative 0.062 t. I want to know how long it takes for this. Now, remember, we just did these problems. I need to free up our exponent, so we've got to get that by itself. So in my case, I'm going to divide by 100. In your case, you're going to divide by whatever that initial amount was. Look what mine gives me here. Did yours end up to be a half? It should, okay? Like John had 5/10 here. Who, give me another number that picked something besides 100 or 10 right here. 12 and 8, okay? So you had 12 here, right? So you had 6 here. So it'd be 6 divided by 12, okay? You had 8, was it? Okay, 8, so this would have been 4, right? So 4 divided by 8 gives us 1/2. Did everybody end up with a half here? You should, because it didn't matter. That's what happens with half-lives. Always, it always happens that way, okay? So now we need to free up our exponent. This has a base E, so we're gonna take natural log of both sides. Because using that property, this has a base E, that has a base E, it cancels each other out, and we're left with negative 0.062t. Over here, we just have the natural log of 1/2. Now we're going to divide by negative 0.062. And so on our calculator, we are going to do the natural log of 1/2 divided by negative 0.062. And we get 11 point, does it say round to the nearest 10th? Yes, 11.2. So our time was 11.2. And does it say in days? It takes 11.2 days from whatever mass that you had, our initial computation, our initial whatever it was, substance. It takes 11.2 days for it to reach half of its whatever mass or whatever it is, okay? Half the amount, I should say, half the amount. Okay? Questions? Not too bad? Because you're going to get some of those and you can pick any number you want. Let's see. Okay. If $20,000 is going to be invested in an account for 10 years, okay, so our P is 20,000. Our time is 10 years. By the way, did she tell you what to do if it was like 8 months? Because you might see that in Alex. I doubt it, but if you do, if it gives it to you in months, all you have to do is put it over 12. If it's 8 months, it'd be 8 12s. 7 months, 7 12s. Okay. All right. That will be compounded continuously. So that tells you that you're going to use P equals E. Oh gosh, no. A equals P times E to the RT. Okay? That's the formula you use when you see this word. Determine the interest rate. So we are trying to find R. We don't know. Okay. So, okay. Let me read this again. If 20,000 is going to be invested into an account for 10 years that will be compounded continuously, determine the interest rate that would allow the money to double. So what is my amount going to be? 40, because it's going to double. I don't know why I put AMT instead of just A. So that's going to be 40,000. We got to figure out what rate we need. So we're going to put 40,000 here. We're going to put 20,000. That was our original investment. That was our principal. E to the R times 10. All these problems are the exact same, aren't they? It's not hard. It just might take a little getting used to. So we've got to isolate this. So we're going to divide by 20,000. And we get 2 because it doubled, right? It was tripled. It would be 60,000 and we get 3 equals E. And I'm going to turn this around and put 10R instead of R times 10. Because I don't like it written R times 10. That's just me personally. How are we going to free up the exponent? Ellen, take the natural log of both sides. And we get the natural log of 2 equals, these cancel, we have 10R. Now you divide by 10. And it says round to the nearest 0.1%. So you're going to do the natural log of 2 divided by 10. Make sure that when you're doing this, that you close that off, that parentheses. I think it'll give you something else. I know it will, okay? I'll show you. Let's figure it up first. And we get 0.0693, blah, 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 right? We're finding a percent. And it says round to the nearest 10th of a percent. That means you've got to multiply by 100, which moves that decimal 2 places to the right. So you get 6.9%. Because that number there is a 3. It wouldn't be a bad idea for you guys to do this. Because what I find happens is you guys stop here and you don't have this or something. I don't know. For some reason, I don't know, people cut it short. So be careful. Okay, if you don't, when we did that problem, it was a natural log of 2. You need to have the calculator do that first to get that answer before dividing by 10. So you have to close that off. Okay, because really what you're doing is you're taking this and dividing it by 10 and you get that. You can do it all at once by doing it like this, as long as you close it off. You didn't have to if you were going to do it in 2 steps. Ooh, not that. Divided by 10. Okay. If you don't close it off and you do the natural log of 2 divided by 10 like this, it's going to give you a different answer. So be careful there. Okay. The number of bacteria in a certain population increases according to the we weren't given this, were we? I'm going to go out on a limb and see if I can remember it. And then I'll check it, okay? The number of bacteria in a certain population increases according to continuous exponential growth model. With the growth rate parameter of 2.7% per hour, how many hours does it take for the size sample to double? I'm not sure on the numbers. I'm going to look it up though, okay? Let's just see if I get it right. Hold on, I got to do the search on the internet. So let me do this because they didn't give it to us. Okay. They just use K instead. Just want to make sure. Hey, I got it right. For some reason, some books, instead of R, use K, right? I know Pearson uses K, I think, at least the notes that we use. It goes back and forth depending on who is the publisher, which one they use. So just know that it could possibly be this. Okay. It could. Just know that K and R are the same thing. Okay. All right. So the number of bacteria in a certain population increases according to this model with a growth rate of the parameter of that. So we're going to get a 2.7%. We're going to move it 2 places to the left per hour. How many hours does it take for the size of the sample to double? Okay. I want everybody to pick a number and place it for P of O, our initial population, okay? P sub 0. Pick a number, doesn't matter, okay? I'm gonna pick 40. Now I'll pick 400. I like using bigger. It doesn't really matter. Okay, this is going to double that, okay? So if this is going to double, whatever yours is, double it. I'm gonna use it, mine will be 800 because I use 400. Yours should be different. Because it's not that big a deal because everybody's gonna end up with the same thing in the end. This here, your P goes here, the doubling one. Your initial amount goes here, 400. E to our rate is 0.027, and we're wanting to find our time. Okay, well, just like all the other problems, we've got to get this by itself. We're going to divide by 400. And over on this side, we get 2. Everybody should have ended up with 2 there. Anybody not? Everybody should have. I don't care what numbers you use. Now, we got to free up our exponent. We're going to take our natural log of both sides. And we get the natural log of 2 equals, these cancel each other out. We get 0.027t. Now divide by 0.027. And we get the natural log of 2 divided by 0.027. And it says how many hours, doesn't really say what to round to. So I'm going to say 25.7 hours, okay? So it's going to take 25.7 hours to double. Guys, these are the kind of things I'm thinking that they probably, when COVID first hit, these type of things, they want to know how long it takes, but anyway. Okay, guys, for now, anyway, I have to go back and make sure. I'm going to look through 21 and 22 and see what those homeworks have, and I'll let you know. But we are, so for right now, I think we're done with all our notes. Okay. When you come in on Friday, make sure if I need you to have something else, I'll give it to you, okay? So make sure on Friday that you come in with what you do. Woo, yay. Nothing to, I don't think. Till I get home and look at the homework 22. So, have a good afternoon. Enjoy the weather.